Hi there again. Now, really at this stage, we've got quite a good knowledge of React's component model, and there isn't a whole lot more about the fundamentals of the model that we need to know about for this module. There are other areas that we won't touch on, but what we know is quite sufficient to build fairly sophisticated web pages. So I want to slightly change focus to other aspects of React app design. So the topic today anyway is behind this card here. The lab obviously is a continuation of our movies app, and some of the areas that we'll be covering in today's lab, in this lab, we will need to address them in the lecture. That's kind of, I'm very much kind of aligning the lectures with what we're doing in the labs. So switching to the slide set for today. These are the three areas that we're going to look at. We need to know how to add navigation or routing to our React app. In other words, how can we have multiple pages in our app and navigate between them? Second topic there, design patterns, is a generic topic. Now, we are obviously going to talk about it in relation to React apps, but the topic itself is quite general. And clearly from the title, it's looking at areas of design of apps, in more so the design of components within an app, or looking at the kind of detailed design part of a React app. And the last topic, obviously we know now at this stage that hooks are a fundamental part of the React programming model. And we've looked at a number of hooks, but they're all hooks that have that are provided by the framework. As it turns out, we can write our own custom hooks, and that's that is kind of related to design issues as well. I'll give you an insight as to how you structure a custom hook. Well, we won't be doing much custom hook development in this module, as it turns out, but I think it's worthwhile just having a brief look at it. So that's the agenda, if you like, for today. So navigation or routing. So the idea is we want to allow ourselves to have multiple views in our React app. But if you looked at the code so far of our movies app, you'll notice that there is only one physical .html file, and no matter what React app you develop, that's always going to be the case. There is always only going to be one HTML file, and we tend to associate a HTML file with a page in the web world. But still, we want to have multiple views in our React app, so there's a kind of a conflict there. And in fact, that's where the term single page app comes from. Your raw code only contains one HTML page in it, but still the runtime behavior of your React app gives the impression that there are multiple views or pages in your app, but which there are multiple views, but there's still only one underlying single HTML page. And so that's where the name actually comes from. But either way, we want to have multiple views in our app. And what's also very important is that every time we change to a different view in our React app, we'd like our browser's URL address bar to change as well. And we'd like the URL address bar to remain in sync with the views as they're changing in our UI. Because that's, again, one of the hallmarks of the web. As you navigate in the static web world, as you navigated from page to page, the browser's URL address changed. We'd still like to have that experience in our React app, even though, as I've already said, there is only one physical HTML page there. And the reason we'd like to hold on to that characteristic of the browser's URL synchronizing with the UI is to do with this quality called addressability, which is a core principle of the web. The idea that every single page stroke view has its own unique address. And of course, the advantage of that is if I want to share a particular view of my React app with you, I don't have to tell you to go to the home page and then explain to you how to navigate to the particular view. I can simply give you the full URL address of that specific view within the overall app. And when you enter that URL into your browser, you will be taken straight to the view that I want you to see. So that's the idea of addressability. Every page or view has its own unique address, and that facilitates information sharing. So information sharing and addressability are all really interconnected, or deep linking is also another term that we use. Browser-based apps have been around for a long while. They predate React or any of these single-page app frameworks. But what was a characteristic of those earlier generation of browser-based apps was that they did not support addressability. Okay, you had this idea of having multiple views and you had hyperlinks, but as you navigated from view to view, the browser's URL address did not change. And that was one of the weaknesses, really, of the first generation. Now, the React framework itself doesn't actually support navigation at all. You might remember in the very first lecture that I gave to you about React, and I talked about the model view controller pattern. I also said that that React only focused on the V part of MVC. And this is another kind of reflection of the fact that the React framework itself has a much narrower focus than all of the aspects of a single page app that you'd like. So it doesn't actually support this, what we're trying to achieve here, this routing or navigation. So we need a third-party library or framework to do it for us. And there are many of them out there, but the library called the React Router library is by far and away the most popular one amongst the community. So it's a completely separate library, this React Router library. It's maintained by a separate team, if you like, but it obviously tries to keep in sync with the re-evolution of the React framework itself. And in particular, we mentioned hooks there last week as a new feature that was introduced into the React framework around 2019. Well, the React Router library, it also changed its programming model to also introduce this hooks idea, as we'll see. But it is a separate library. So there are a number of aspects of this React Router library and consequently a number of aspects of routing that I want to demonstrate. So I've got a number of samples to demonstrate each of the features one by one. I won't get through all of these samples today. I'll just get through the few that we need to support this week's lab, and the remaining samples I'll cover in a later lecture. So the samples, if you again go back to the website and download the archive. Now, in this case, so this is the folder that has been created when I unzipped the archive. This is not the folder that you import into VS Code. If you drill down into it instead, so if I go into that folder, I've got two subfolders. Now, for this routing samples, this is the folder here that I need to bring into VS Code. And so if you expand the source folder, you can see there's numerous samples here. This is the way I decided to structure this. And the way you get any one of the samples to work is, okay, first of all, you start up your development server. So we're back to using the Vite tool now again. And you start up your development server. Which is npm run dev. And depending on what sample you are studying, the way you get that sample to run is you go into the base index.jsx, which is this one here. and you change it to the sample that you want to look at. So if I want to look at sample 4, let's say, just change it to 4, save it, and the Vite server will take care of the rest, and it'll update the browser to now be looking at sample 4, whatever that's dealing with. So we want to look at sample 1 first. So the kind of 101 of using this React Router library is as follows. Supposing we've got this requirement, we want to have 3 views in our app, and we want the URLs associated with those views to be as shown here. And this is the component that I want to have mounted when the corresponding URL is in the browser's address bar. So the way I interpret this now is if the browser's URL is just slash, in other words, localhost 3000 slash on its own, then I want the home component to be mounted onto the DOM. Now, in my case, the home component won't have any children, but in real life it would. And so the home component would effectively be the top component in my home page, for example. If the browser's URL changes to /about, then I want the home component to be unmounted, and consequently all of its children unmounted. And I want the about component to be mounted in its place. So I'm effectively navigating to the about page. Again, about may have loads of children, even though they don't in my case. And similarly for the third example here. So I've got 3 pages with these particular URL requirements. Now, how do I express that in my React app? And this is how you do it. So again, it's following the kind of React programming model. It's, it's declarative, etc., etc. So you can see here that I've, if we drill down a little bit, I've got a route entry corresponding to each row on my table on the left. And so again, I think it's fairly understandable. This is saying if the browser's path is /about, then this is the component that should be mounted. Similarly, if the path is /inbox, this should be mounted. The index path is always what's referred to as the root path, which is just the slash on its own. I want the home component to be mounted. The way you interpret this one here is if the path is anything other than any of the above, so it's kind of the default case or the 404 case, then notice now in this case, I'm mounting a component called navigate. Navigate is a special component provided by the React router itself. And it's not so much that the navigate component is mounted onto the DOM. What the navigate does is it changes the browser's URL address to whatever you specify here. So in this case, the effect of this piece of code is to change the browser's URL address to /. Now, I should say every time the browser's URL address changes, this code here, this routing configuration code, is consulted all over again. The React router library, in other words, kicks in and deals with the event, because when the browser's URL address changes, that is modeled as an event by the browser itself. Remember, our browser is an event-driven environment. So when the browser's URL address changes, that triggers an event within my browser. And the React router library will have already registered an event handler to deal with that case. And so the event handler, what it does is it essentially kind of consults these root entries here to decide what changes need to be made to the DOM, what components need to be mounted and unmounted. This is a slightly different case, the way it deals with this. When the browser's URL address is none of the above, then okay, technically the navigate component is mounted onto the DOM, but it doesn't display anything on the screen. What it does is, as I said, it changes the browser's URL address to something else again. In my case, this. And of course, now if the browser's URL address changes to just /, then that triggers an event in the browser. The React router library deals with that event. And in this case, it handles the event by making this root entry here the active root entry, if you like. In other words, it mounts the home component onto the DOM, and my home page is displayed. So that's what's happening behind the scenes when the browser's URL address changes. So what we could say is that the code here in my little code snippet, it is a declarative style of coding, which is consistent with the React programming model. There are some other components playing a role here as well. The browser router component, that's the one that kind of decides, it looks at the various root entries and looks for a match. So it matches the browser's URL address to a particular root entry if it can. If it can't, then it takes the default case. The root entries, they're components and they have props, if you like, and element is a prop, as well as path. And I've already told you that whatever JSX is assigned to element, that JSX is mounted onto the DOM. And in fact, it can be any JSX. It doesn't have to be just a component. Okay, in all of the examples that you see here, the element is assigned a component, but it can be assigned a piece of random or arbitrary JSX, and you'll see that a little bit later on. I'm saying here it can take any arbitrary JSX. The index case I've explained, and the hash case or the asterisk path case I've already explained as well. The routing configuration, which is what we refer to this as, that's typically the JSX associated with the component at the very top of your application's component hierarchy, which conventionally we name the app component. It doesn't have to be, but it is in this case. So the app component, typically all it has is routing configuration in it. It can have other stuff as well, and as we work our way through these routing samples, we'll see that we can put in arbitrary JSX in here as well. For example, if you want a static header across all your pages, the static header JSX would appear within this app component. And we tend to refer to the app component as our router component within our overall app. So I'm just showing you the routing configuration of sample one. The rest of the code in sample one is trivial, but just because it is the first sample. So for convenience, I've put a number of different components into my index.jsx, but it's purely for convenience. So if we scroll down to the bottom of this, okay, there's my routing configuration that I've shown you, and here's the boilerplate code, and you can see that I am mounting the app component onto the DOM. Now, the other components then, home and about and inbox, they're just here just for convenience, as I said. So they're my pages. And so if I run sample one, which I think is already running. And again, so the browser's URL address is currently on the root, if you like. But if I change it manually for now anyway, if I change it to about, and you have about page mounts, and similarly for the inbox. And if it's anything else, then it goes back to the home page based on that fourth entry in my routing configuration. So that's the 101 of routing. You define your routing configuration in the top component in your app's component hierarchy. If you want to have hyperlinks, then you should use a component provided by the React Router library itself called the link component. And by using that, you will get access to other useful props and objects that are made available by the React Router library, and we'll see some of them later on. So what I'm saying here is if you want to navigate to another part or another view within your React app, you should use the link component. You can still use the standard HTML anchor tag if you want to have a hyperlink to something external from your app. And so if we look at sample 2, so the idea of sample 2 is I have these 2 hyperlinks at the top of my page, and clicking those will do what you expect it to do, take you to the relevant page. So how do I actually implement these hyperlinks here? And so we implement them using the link tag. And for now, the link tag, which you can see here, for now it just has one property, the top prop, and we assign that a path name. And again, the way it works behind the scenes is when the user clicks on the hyperlink, that changes the browser's URL address to whatever you specified here. And everything that I was explaining earlier on about what happens when the browser's URL address changes, that applies again. So the browser's URL address changes to whatever you specified here. That triggers the browser to fire an event. The React Router library handles that event, and it consults its routing configuration all over again to decide how it should change the structure of the DOM, if you like. So just to see it working, I go down to my base index.jsx, and I want to look at sample 2. I can leave my server running in the background. Now, for now, my hyperlinks disappear. Obviously, that's not great. We'll fix that in a while, but they do work as I'd like them to work. And you can examine the code for sample 2 yourselves. Next is what React Router calls dynamic segments, which is kind of an odd term, but a clearer name for it would be parameterized URLs. So parameterized URL is a URL where one part, or maybe more than one part of the URL, is actually a variable, and that variable has some meaning within the context of your app. So for example, let's supposing this might be a valid URL for a particular app, React app that we have, where the 22, let's say, represents a user's ID. Or in this case here, it looks like maybe 1, 2 again is a user's ID. So presumably, whenever the browser's URL address changes to this, we want to display all the purchases made by user number 12. Whereas maybe this one here might display the user's profile, but the profile would depend on this particular part, this variable part of the URL address itself. And so our React components need to get access to the variable part somehow, and presumably maybe do some sort of database lookup or web API invocation, which does a database lookup to get the relevant data. So the 2 questions are, how do we declare a parameterized path within our routing configuration? And number 2 then, how do we actually make the parameter value available to our React components? So to stick with our simple little case study, our case study is Maria, an email client. So we have this inbox page in our fictitious email client, and the inbox page presumably should maybe display a particular user's emails that they've received. So we're saying, suppose the inbox component shows the messages for a specific user, where the user's ID is part of the browser's URL address. So maybe this might be a sample URL for my application. But of course, this part here can vary. Now, how do we express the fact that this part here can vary within our routing configuration? And the answer is use a fairly common approach to using it. You'll see this across a number of frameworks, wherever the colon appears in the path of a route entry, that tells the React router that this is a variable or a parameter within the overall URL address. Whereas inbox is going to be static, the value here can vary from time to time. And I've decided to give a name to the parameter, and I've arbitrarily decided that user ID is the name of the parameter. Okay, and I still want the inbox component to be mounted. But the question now is, how does my inbox component get access to the particular value that appears here in the browser's URL address bar? And I think I actually show you on the next screen. So we'll just look at the next screen before we show the working. So here's my inbox component. And here's a hook that is made available by the React Router library. And I mentioned there earlier on that the React Router library tries to track the React framework itself in terms of how it approaches things. So I think it was version 5 of the React Router library, they introduced hooks into their programming model as well. Prior to that, we had to get access to the parameter in a slightly different way. So this is a hook that's made available to us, and it returns an object. And you can see here, I'm just using destructuring on the object. And I know that one of the keys within the object is going to be user ID. And I know that because that was the variable name that I used in my routing configuration, which I showed you on the previous screen. So I'm extracting, so now I'm declaring a local variable here called user ID, and the value of that local variable will correspond to whatever user ID appears in the browser's URL address bar at any point in time. And of course, that can change. Now, all I'm doing it with the user ID is I'm just displaying it on the screen. But typically, you might have a use effect hook here, which uses the user ID to make an API call to a backend service to get, let's say, the user's set of messages and then display those messages on the screen. So the use params hook is just one of many hooks that are part of the React Router library, and we'll see some other hooks later on. And in most cases anyway, they do return an object, and we just dig into that object. You need to understand the structure of the object, but it's fairly straightforward in this case. In general, when you've got parameterized URLs, you can have more than one parameter within a path. So for example, here, let's supposing I've got both user ID and also I've got category number or category name, sorry, as another variable within this overall path. And that's fine. And it'll all work as you might expect. So the use params hook in this case would return an object that contains two key value pairs corresponding to my two parameters or variables in my path structure. I think this is sample 3. So if we just quickly look at sample 3. So again, just for illustration purposes, I've just got two hyperlinks here. And when I click on these hyperlinks, notice what happens to the browser's URL address. And based on my routing configuration, it is going to load the inbox component, which I've shown you the code from there. So if I click on this one first, the browser's URL address changed to this. So it looks like the user ID is 123. And that's why I'm 1234, sorry, and that's why I'm getting that here. So that kind of confirms to me that my inbox component is accessing the parameter within the browser's current URL address. And to further reinforce that, if I click on this hyperlink, the variable part now has 5678, and I'm picking up 5678 here. And just to glance through the code, even though we have the essence of it, but here's my routing configuration. And the only new route is this one here. And the inbox component, in this case, the inbox component is in a separate file. Here's my inbox component, and that's the code that we saw on the slides. So you can play with that yourselves if needs be. The next feature, I don't use it in the movies lab. If I were to use nested routes, we'd have to do a fairly significant kind of restructuring. It is quite a nice feature. So that's why I'm including it here, even though I don't use it. And so the idea is where you want a component's child to be dynamically determined based on the browser's URL address. So it's the same kind of idea. The URL address dictates what components get mounted. But in this case, it's slightly different in that we have a component, but it's the children of that component. We want that to be determined as well. That hasn't been the case so far. You know, in the previous example, it was always the inbox component that was being mounted based on the root entry in my routing configuration. And okay, there was a parameter that was being used by the inbox component, and it was using that parameter to change what the inbox component displayed. But it was always the inbox component that was being mounted. In this case, I want a component to be mounted, but I want its children to be somehow dynamically determined, again, based on the browser's URL address. So I tried to kind of come up with some sort of example of this and sticking with the whole kind of inbox idea. So we're told here that given that you've got this route entry in your routing configuration, so that's the one that we've had all along so far, we're saying furthermore down here, if the browser's URL address has this structure to it, in other words, if there's a slash statistics part appearing after the user ID part, then I want the inbox component to be mounted as before, and it can do all it did before previously. But I want it to have a child component, which is going to be the stats component, which let's say that displays some statistical information about the browsers or about the user's inbox usage. Over here, then I've got a different scenario though. If slash drafts or draft appears at the end of this URL address, then I want a different child component to be mounted for inbox. So that's the objective. And in other words, I want draft and statistics to be nested within my inbox, but which one is nested at any particular time depends on the browser's URL address string at that time. So how do we achieve that? And we express it in the routing configuration. Surprise, surprise. So it starts up here. Okay, here's my inbox slash user ID as before, and I mount the inbox component as before. But the nested inside it are inner route entries. And the path name for these inner route entries, it's very important that the path name is expressed in relative terms, whereas this path name here is absolute. You've got to make sure you express these in relative terms. So this is, the statistics is relative to this part here, which means it's tagged on at the end. And we want the stats component to be mounted. Similarly for the drafts case. The third one is, well, what do we want to happen if the browser's URL address is just /inbox/1234 and nothing else? I've decided that I want the filler component to be mounted. This third option here is arbitrary. The only reason I might want to use the third option is to put something on the screen where the stats component and the drafts component would normally display something. Otherwise, you just have a white space in your screen, and that may or may not be, from a visual point of view, a good look or not. So this third option is optional, really. So yeah, I've mentioned already that it's important to use relative path names in these nested root entries. This is what we refer to these as. The index root is optional, which I've already mentioned. Now, the question then is, in the actual inbox component itself, this one here, how do we tell it where to put my stats component or my draft component? Where should it kind of physically appear in the UI? And you do that using this outlet component in the inbox itself. So this is all sample. What sample are we up to? Sample 5, I think. Sample 4. Let's see. So this is where my inbox is. If we look at the URL address, the URL address doesn't have anything after the user ID. So my inbox is just giving me all of this. And if I try this link, we now have statistics at the end of the URL address. And so just for simplicity's sake, this is what the statistics component generates. And similarly for the third link is demonstrating the draft. If we just glance at the code itself, so that's what I showed you on the PowerPoint slide. Okay, and if we look at the inbox component, it has a lot of what it had before. Here's where I use the outlet to position the contents of either the statistics or the drafts or the filler. This message component, that's not significant. That's just local here. I've just refactored, sorry, this is message component here. Just refactored it a little bit, and I have my filler component as well. The extended link idea. We've seen the link component already, and we use it if we want to implement hyperlinking to a different view in our app. But sometimes when you click on the hyperlink, and the ultimate effect of clicking on a hyperlink is a new page or a new view is displayed, or new components are mounted onto the DOM and they replace other components. But supposing we want to pass some data to the new components that are mounted onto the DOM, how do we actually express that? So somehow the link needs to be able to pass data to the new component that's mounted. And we do that, or we achieve that, using an extended form of the link component itself. So that's our objective, supplying additional data. And we illustrating it in sample 5. Now, again, it's a kind of a hacked example, but in this case, this inbox hyperlink here, if we look to the actual implementation of it, so again, we've got the link component. And it's got the to prop as before. Sorry, I'm looking at the wrong one. Here's my link component for the inbox. It's got the to prop as before, but it also optionally has a state prop. And the state prop, you can assign it this additional data, whatever the additional data is. And typically, it's going to be an object. Now, again, I've just hacked it. So you can see here at the top, I've declared a local variable and I've just assigned it a string. And I want to pass that string onto, in my case, onto the inbox component, because presumably it's the inbox component will be mounted in this case. So here's the object that I want to pass to my inbox component. And then the question is, how does the inbox component get access to this? So before I move off from this slide, my root entry is the same as before. That hasn't changed. So how does the inbox component get access to this additional data? And surprise, surprise, there's a hook that will do it for us. Now, before I talk about the hook, every time the browser's URL address changes, the React Router library creates an object called the location object. And that location object contains information about the new, if you like, the new value of the browser's URL address and properties of the new URL address that's in the browser. And it puts this into an object which we refer to as the location object. And I did a console.log of the location object from my inbox component, and this is what it looks like. Now, most of the properties of this location object are not of any particular interest to us. Path name, okay, is mildly interesting. That's going to have the string corresponding to the current URL address in the browser. But here's the state property within the location object. And it's the state property that will contain this additional data that I've tagged on to my link. So my inbox component needs to get at this state property within the location object. And conveniently, we can do that by using a special hook provided by the React Router library yet again. So it's the use location hook. It doesn't take any arguments, and it returns an object. And the object it returns is the object that you see on the left. And all I'm doing here is I'm actually carrying out destructuring. The nice thing about destructuring is you can use it to drill down into nested objects within an object. So in my case, I want to drill down into the state property within my location object. And that's really what I'm doing over here. So the net effect of this statement here is to create a new local variable called user profile and assign to that local variable the value corresponding to the user profile property within the state object within my location object. And there's my user profile property here. So it'll just be the string in my case. More generally, it might be a fully fledged object, but it's just a simple illustration of it. We do use this location object, not in this week's lab, but further down the line. So we'll have to revisit that. Okay, so that's sample, I think that's sample 5, which you can look at yourselves. And there are, I think, 8 samples in total routing samples. So we'll look at the remaining 3 in subsequent lectures. Now I'm going to switch focus and talk about the area of design in relation to React apps. Now, in relation to the design of React apps, I suppose there are 2 parts with really. One part is, how do we actually come up with a component hierarchy? How do we decide which components are stateful and stateless? Now, that's not what I want to cover here in this set of slides, though. I have a separate about 30-minute lecture explaining the process that you go through to answer those questions. And I think I'll probably release that to you for next week, so you can look at it in your own time. What I want to look at today, though, is more design within an app itself. So if you've got a particular subset of components or a subset of, let's say, a feature within a React app, and you want to design it from a set of components point of view and relationships between those components, that's really what I want to look at today. But if I broaden out this issue first and talk about what we mean by design patterns. Design patterns is a topic. It's a software engineering topic, right? It's not specific to web apps. It's software development in general. And the text, the book cover that I'm showing you here on the left, is a book that was released way back in 1995. So design patterns has been an issue for a number of decades. And what is a design pattern? I'm kind of giving you a definition of it here. I'm saying in software engineering, a design pattern is a generalized, repeatable solution to a commonly reoccurring problem in a software application. So if I go back to this textbook, what the authors of this book did, and remember now we're going back to the mid-90s, which is quite a long time ago, but what they did was they looked at the actual implementation of a broad range of software applications. They weren't necessarily web applications, just software applications in general. And they essentially kind of dug into the internals of those applications and tried to identify parts of the application that they felt were well designed or well structured from a modularity point of view. And where they found good instances of well-designed features within these applications, they essentially documented the design. They abstracted it into a more general case and then documented those designs. And so they came up with a whole catalog of these good designs, and we kind of refer to the designs as design patterns, because the way they documented them was not specific to the application they were looking at. They documented them in a more general sense. And by that, I mean, the documentation might say, well, if you've got this particular type of problem, and they would describe the problem in as general terms as they could, then they explained how you might structure your code to implement a well-designed solution to that particular type of problem. So they, as I said, they produced a whole catalog, and they even grouped the various design patterns that they documented. They grouped them into categories. I think there are about 4 categories in total. So this textbook was the first text dealing with this topic called design patterns. Didn't exist prior to that. Now that was way back in 1995. A number of newer patterns have emerged since then, and equally they've been documented as well by various members of the software development community. So, you know, there are design patterns out there for various types of software applications. Clearly, we are only interested in web applications, but the topic itself is generic. Now, when you're talking about design within a software application, two kind of generic objectives that you might have are the reusability objective and the separation of concerns objective. Reusability, I think we're all kind of familiar with. We'd like to have the modules or units within our application to be reusable, either within the application or across applications. Separation of concerns is this idea that each unit, be that a class or a function or a component or a module, each unit should really be focused on one particular concern within the overall set of concerns of an application. I'm sure you've heard of these in different aspects of the software development and software studies that you've done yourselves. Kind of related to reusability and separation of concerns is this DRY principle, which stands for don't repeat yourself. Again, they're kind of interlinked. We never like to have repeating code scattered across our application. If we see instances of the same kind of code being repeated more than once, then clearly the solution is to abstract that code or to refactor that code into a unit or module of its own and reuse it wherever it needs to be reused. So the DRY principle, reusability, separation of concerns, single responsibility, that's another term that we use. They're all kind of interrelated, and they're all concerned with trying to improve the design, the internal design of our application. And equally, that was the concern or the objective of these various design patterns that are being documented by the authors of that book that I was mentioning. Now, in very, very general terms, there are kind of two techniques available to us for improving the dryness of our code. One is called the inheritance approach, and the other is called the composition approach. And this is a way of how you might approach modeling the particular problem domain that you're developing a software solution for. So the inheritance approach towards modeling your problem domain is to try and look for what are referred to as is-a-type relationships in your problem domain. And so a very simple example might be if we were developing some software for an automobile-related application, then car is an automobile is an example of an is-a-type relationship. And so you might visualize, or you could imagine that if we were using a class-based programming language, then presumably we would have a class with the name automobile in our class hierarchy, and the automobile class would have a subclass called car. That's how you might model it from an inheritance perspective. Whereas if you kind of viewed your problem domain using a kind of composition approach, then you're not looking for is-a-type relationships, you're looking for has-a-type relationships. And again, sticking with the same context, a relationship between a car and an engine has a type relationship. So again, if we were going to implement this using classes, then we might imagine that we would have a car class, but in this case, one of its properties would be a property of type engine. So these are just two alternative ways of trying to model the particular problem domain that you're developing your software application for. And why do we do that? Well, we want to try and improve the reusability of the units within our application, be that modules or classes or functions. We're trying to improve the separation of concerns. We're trying to maximize the dryness. That's why we would try and either apply one or the other of these approaches. And it tends to be one or the other. You can mix them as well within the one software application. Now, where I'm going with this is React is more focused on the composition approach towards design. And we don't use inheritance at all. And coming back to the kind of the title of this set of slides, which is design patterns, there are actually design patterns that have emerged over the last 10 years or so, specifically linked to React component app development. Some of them have reduced in their importance in kind of more recent years, but the three ones that you would tend to come across when you're if you're Googling around this would be the container pattern, the render props pattern, and the higher order component pattern. Now, I'm only going to look at the first two because they are the two that are still relevant. The higher order components pattern is less relevant today, mainly as a result of the introduction of hooks to the React programming model. Now, before I talk about React, we can kind of go back to basics, really, and talk about, if we talk about HTML, which is a language, and therefore, does it actually follow any kind of one of these approaches, this composition stroke inheritance approach? Well, in fact, it's based on the whole composition idea. And we know this anyway, I guess. But if I was to describe this piece of HTML from a composition point of view, I would say that my div element is composed of a H2 and a UL. And my UL element is composed of a number of LI elements. Equally, we could use the language that my div element has two children, because this term children is going to be relevant to our React component relationships as well. On the right, just as another example, I have a div component and it's composed of a paragraph and an image and a hyperlink. Or equally, I have a div element and it has three children. So let's return to the topic of patterns. And the first one I want to look at is the container pattern. Now, there's a feature of React that we need to be aware of in order to understand this pattern. And I'm explaining it here in the text. I'm saying all React components have a special children prop. Now, what's the purpose of this children prop, or how can we avail of it? And I'm saying what it does is it allows a consumer component to pass other components to it by nesting it within the JSX. So there's three components at play here now. There's the reusable component. There's the user of that reusable component, which we refer to as the consumer component. What the consumer can do is it can pass components to the reusable component, and the reusable component will then include those components that have been passed to it. It will include it in its output or in its JSX. Here's an example of a reusable component in this context, which I've called the picture component. And if you look at the JSX of this picture component, you see that within the JSX, it's referring to props.children. So whatever that expression returns, which hopefully is JSX, that JSX is included in the overall output of picture. On the right, I'm showing you a consumer of the picture component. In other words, it's using it. And so here's where it uses the picture. And I'm using kind of standard HTML in that I've got an opening picture tag and a closing picture tag. But nested within those opening and closing tags, I can put essentially any HTML stroke JSX that I want to. And whatever JSX I put here, that JSX will be bound to the prop, to the children prop of picture. So when I go props.children here inside in picture, it will be equivalent to or assigned this expression here. So the container determines, the container or the consumer, it determines or it controls what the picture renders. And so different consumers or different containers may have different use cases for reusing the picture component. So we're essentially kind of decoupling the picture component from some of what it displays, and the sum of what it displays is controlled by the consumer. Some examples of that. Here I've got a consumer that's using a picture component to include a button with the picture. Here's an example of a consumer that's reusing the picture component to render an unordered list with the image. And a third example where I want my picture to include some custom component with the image. So 3 different reuses of my picture component. And so in the language of the container pattern, we would say that the picture is composed with other elements or other components as dictated by the consumer. So it's simple enough, really, this container idea. The patterns themselves, if I just go back in general, the patterns themselves are easy enough to understand when they're explained with particular examples. The difficulty tends to be identifying an opportunity to use a pattern. That's where the skill comes in, and really it's more experience that you need before you can spot an opportunity to use a particular pattern for a particular problem that you're trying to implement a solution for. Anyway, that's the container pattern, which arguably is straightforward enough to understand, but as I said, seeing opportunities to use it might be slightly more difficult. The second pattern that I mentioned was the render props pattern. What you'll notice about a lot of the patterns is that they're all trying to achieve the same thing, this kind of reusability, separation of concerns, dryness, but they go about it in a slightly different way. And also, you know, the circumstances might dictate that you would have to use one pattern over another. It's not so much that you could use any one of the patterns for any particular problem. So they have particular use cases that they are more appropriate for than others. So what's the objective with the render props pattern? Well, we use it to share logic between components. Surprise, surprise. That doesn't tell us a whole lot. But that's really was the idea with the container pattern as well. We were sharing the picture, if you like, with we were reusing the picture or sharing the picture in different circumstances. A definition of what I mean by a render prop. Well, we know what a prop is. It's something that's passed into a component. When I talked about props at the very beginning, I said we use props as a way of transmitting data from parent down to child. Then last week, when we were looking at the data down, action up pattern, we realized that a prop could actually refer to a function, and the function was being passed by the parent down to the child so that the child could invoke it when a particular event occurred in the child component. Well, in this case, the prop is also going to be a function, but the receiving component, the component that receives this special function, it invokes it in the middle of its JSX, and the invocation of the function is going to generate some JSX. So the definition is that a render prop is a function. It's a function prop, or it's a prop that is a function that a component uses to generate part of its rendered output. In other words, it's JSX. Let's look at a kind of a silly example, if you like. So I've got this component, which I purposely called shared component. So this is the one that's going to be reused. And a bit like the children's prop, you can see here in the middle of its JSX, it's invoking a prop called render, but it's invoking it as a function. So whatever this expression returns, which presumably will be JSX, that's going to be inserted into this containing div in this case. So in this case, render is a function, whereas when I was using the children's prop, that was just, it wasn't a function as such, it was more referring to, if you like, an object, if you like. So how does the consumer pass down this render prop? Here's my consumer in this case, and it's using my shared component. And here's the render prop, and I am indeed assigning it a function, albeit the arrow style in this case. And the function is trivial, right? It's just returning a span. So when this say hello component renders, its net effect is to essentially generate this overall HTML. My span is going to be inserted within the div, the div being provided by my shared component up here. So it's quite similar to the children idea, but it's just a different way of achieving it, and there are different use cases for it as well. There are some cases where the render prop is the only approach towards achieving whatever you wanted to achieve. The container approach wouldn't work. So the shared component receives its rendered logic from the consumer, as I said. And the prop name itself is completely arbitrary. It doesn't have to be called render. There's no significance to that. That's just the convention. So to try and give you a slightly more real example or illustration of this, I've got this sample app, and it's back to my kind of filtered friends idea again. We know what that how that works from last week. But supposing I've got two different ways that I want to display my friends. In one case, I want to display the friend's name and an image, whereas in the other case, I want to display the friend's name and their email address. And clearly, we could deduce that there must be a way of sharing the code that actually generates the list of friends. Now, in this case, sorry, now, okay, we'll stick with the slides actually. So on the left here is the design of this filtered friends app from last week. Okay, so this design now is last week's design. And I'm highlighting the fact that the way it worked last week was this component here, it had an import statement hard-coded in the code, and the import statement imported the friend component. So that meant that filtered friends list could only render friends in a particular way because it was hard-coded into the actual code itself. But now we want this component, this filtered friend list component, to somehow change the way it renders friends dynamically. So we can no longer use a static import statement. And the way we get it to achieve that is this component here is essentially going to tell filtered friends list how it should render friend components. And it'll communicate that using this render prop pattern. So the change that I'm going to make to this old design, I'm documenting over here. I'm saying the friends app, which is the component at the top, it's going to pass a render prop to filtered friends list. And that render prop will indicate how friends should be displayed. And the particular value of that prop can change somehow, maybe based on some interaction from the user themselves. In my case, if I go back to the previous screen, it's not clear from here now, but I've got two tabs here. And so if I click on this tab, it renders the friends this way. Whereas if I click on this tab, it's going to render the friends the other way. And clicking on the tabs will trigger some piece of logic in my friends app component, and that's going to determine how it should tell the subordinate to render friends. Also, we're going to remove the static import statement that used to appear inside here. So the code for this example is the third folder in the archive that comes with this week's lecture. And so if I pull that in, and again, it's a simple Vite project. So if I run it first, and here are my two tabs. And so the key component is the friends app. So before I look at that, so I've got a friend contact component here. That's the component that renders a friend by listing their email address with their name. I've got the friend image component, which renders a friend by listing their name and their image. Then I've got filtered friends list. Now, I've left it here, right? But here's the import statement that we would have had last week. But that's no longer active now. And okay, this is receiving my array of friends as before. All I'm doing here now is I'm using destructuring on the props object. So there's two props being passed down to this component. This is going to be just a list of friend objects. And as you can work out, this is the render prop pattern. And I'm using that render prop here. It is a function, so I'm calling that function. And the function expects an argument in this case. It expects a friend object, which item will be, because I'm mapping over. I'm mapping over my friends. So item is going to be a friend object, and I'm passing that to my render prop. So we still haven't seen what this render prop function looks like. And so the detail of that is going to be up here. Now, first of all, here I'm importing the two different ways of rendering a friend because I am going to need both of them potentially. I have my state variables. This is the same as before. This is just going to hold on to the current contents of the search text. So the search text, that works as before. Does that kind of filtering. So there's nothing new there. This is always going to contain my full list of friends. This third state variable is the one that I use to determine which of the two tabs has the user clicked on. In other words, Which of these two tabs have they clicked on? And you can see here, the statement here, I'm checking the current value of that state variable, the format state variable. And if it's equal to image, then I'm assigning one of my friend components to a variable called friend. Whereas if it's not equal to image, and presumably now when I click on those tabs, I change this state variable to be equal to image or to be equal to a different string, and we'll see that in a moment. But friend is going to be assigned one of my two component types. This is just making the API call to the random user, so there's nothing new there. This is the event handler for my text box, nothing new there. This is where I do my filtering of the friends, nothing new there either. So if we scroll down to the tabs, now I've implemented the tabs as buttons, and the on-click event handler for my tab stroke button, it's changing the format state variable. So I either set it to image or I set it to contact. And as I mentioned, that's why up here I'm checking to see, well, is it equal to image? If it is, then that's the way I want friends to be rendered. Now I still haven't shown you the render prop. The render prop is passed down to my filtered friends list. Here's my filtered friends list, and here's my render prop. And I'm passing down a function, and the function returns a component of type friend. Friend is, if you remember, is instantiated here. So it could be equal to one or other of these two. And in this case, my render prop function, it is a parameterized function. The function expects, when it is invoked, it expects to be passed a parameter. In this case, the parameter would be a friend object or a user profile object from my random user web API. So that's quite tricky. So now that we've seen the structure of my render prop function, you can see, hopefully it makes more sense when we go down to the actual filter friends list. You know, we're invoking the render prop function and we're passing it a particular user profile or friend object. There's just one other thing that I noticed there, which is not really linked to render prop, and it is, see this property here, the key. When you, I probably should have and could have mentioned this certainly last week and maybe even prior to that. When you've got, well, sorry, let's do it this way, right? This here is going to be an array of components, be it friend image or friend contact. Either way, it's an array of components, all of the same type. And here I'm just rendering that array. In React, when you've got an array of components, you should, rather than must, you should specify a key property for each instance in that array. And that is what I'm doing here in what I've just highlighted. I'm actually passing in a key property to friend. Now, I know I'm jumping around the place a little bit, but if I just leave that open, and if I go into my two friend components, you know, they're not using There's nowhere here where I'm using this key prop. So it's not really of use to me directly, but it is used by the React framework itself. And it uses the key property to distinguish between one instance of a component in my array of components from other instances. And it helps the React framework when it's mounting and unmounting and remounting components. That's where it actually helps the React framework itself. So the message is, whenever you've got an array of components, then make sure that you always include a key property in the entries in that array. And you can assign the key property anything as long as it's unique within the array. In my case, I'm assigning it a friend's email address, and that is going to be, they're going to be unique. And that unique characteristic, as I said, it helps React when it's doing its mounting and unmounting, and when it's computing updates to the DOM, by looking at the current and previous version of the virtual DOM. You might remember all of that from last week. What I could do actually is if I did the following. I know now we've moved away from render props, but if I just open up my developer tools and I open up the console, I'm just going to do a manual refresh. Okay, so that all looks fairly clean. Now, if I go back to my code and I remove this property, which, I'm not using it in my own code, so why do I need it, you might ask? And I save that. You see the error that I'm getting here? This error is coming from, it's a warning. I mean, my app still works okay, but the error is, or the warning has been generated by the React framework itself. And essentially it's telling you that, look, you've got an array of components, but you haven't given me, the React framework, a unique key for each entry in that array. So if I go back and put back in my code, put back in my key, that warning message goes away. Should go away. If I do a manual refresh. Okay, it's gone at this stage. Right. The last topic I want to look at in this lecture is custom hooks. So we know at this stage that hooks is a major part of the whole programming model, the React programming model. There are hooks that come with the React framework itself, and most up-to-date third-party libraries that are focused on React also provide hooks. We'll come across two of them actually in next week's lab. But we could actually design hooks as part of our own application. And so that's why I'm classifying them as custom hooks. They're just hooks that are specific to our application, our software organization, if the hooks are possibly applicable across multiple applications. So it's not the preserve of the React framework itself or third-party libraries. We can write our own hooks. And really, all I want to do is make you aware of the possibility, rather than expect you to be able to identify opportunities to refactor some of your code such that you can introduce your own hooks. We will introduce one custom hook in the Movies app, so you'll just get an insight into it. And it's still kind of under that general area of design, because we're always trying to improve the design of our code, whether it be React code or any code. And our objective always is, when we're trying to refactor, we're trying to improve the design, improve from a reusability, understandability, maintainability, all of those kind of characteristics. So it's still kind of consistent with that whole design theme. So custom hook is a hook that we implement ourselves. And typically it arises when you see an opportunity to extract some code, some logic from a component and put that logic into a hook, into a function, really, because a hook is nothing other than a function, but into a function that is going to behave like a hook. It's not specific, but usually the logic that you're extracting from an existing component is kind of state management logic. And the example that I'm just going to show you now is in that kind of vein. So let's supposing we have this fictitious library management system, and there's a component called the book page, and it's fairly obvious from the component name what that component does. It displays details about a particular book, let's say. And so at the moment, the way we've written it, we have a state variable that we've got a useState hook that looks like it's going to contain a reference to the book object itself, and it allows us to change the book object. In other words, change what page, or change the page to look at a different book, a bit like the movies details page, I suppose. We've got a use effect hook that's more than likely making an API call to some backend that is going to provide the book details. All fairly standard stuff. Now, this logic, let's supposing there were other pages in our app that required this kind of logic as well. So we don't like repeating code. So can we extract that code out of that component that we're looking at and put it into its own location? And the answer is yes. And that function that we're going to create and store that code in is an example of a custom hook. And so simply all you do, it's very straightforward in this case, you simply lift that code and put it into its own function. And I've purposefully and necessarily, I've called the function, I've prefixed it with the use prefix, because all hooks should begin with that prefix. And I explained kind of roughly why it's important to do that, because there are tools called linting tools that come with the JavaScript in general, but the linting tool that comes with the React framework, with the Create React App tool, sorry, the linting tool that comes with the Create React App tool, what it does is it scans through your code to make sure that you are using hooks appropriately. And I've told you before about the fact that you can only invoke a hook at the top level within a component. You can't bury a hook invocation inside, and let's say an if statement or inside in a for loop. That's not permitted. I never went into the details as to why it's not permitted. It would require a bit more understanding of JavaScript and all of that. So we'll just have to accept that that is a rule that you have to adhere to. Now, my hook, because it contains useState and useEffect, it contains two native hooks to the React framework, my hook has to adhere to those rules as well. So by me prefixing this function name with use, that means that the linting tool that comes with Create React App will also check to make sure that my custom hook is being used appropriately. But other than that, I suppose it's just an ordinary function, which I've implemented using the arrow style. Now, it would make sense, I suppose, that this function be passed in the ISBN number, because that seemed to be what drove this code here, right? The user entered an ISBN number. Well, in my case, it's kind of being passed down as a prop, and that ISBN number presumably is being used here to make the API call. So it's an important parameter. It would be an important parameter to my custom hook as well. because I'm still using the use effect hook here, and the ISBN number is being used somewhere. It's being used here. Look. So, so the parameters to my hook are you choose them sensibly, obviously, and this would be a sensible parameter for and necessary parameter for this custom hook of mine. In terms of what a hook returns, a hook can return anything you want it to. It just turns out, in my case, that the hook is returning essentially the same data that the useState hook returns. Where am I going to? Sorry, sorry, just give me 1 second now. Oh yeah, the useState hook here is returning a book object and the setter method, and it just turns out that my custom hook is returning the exact same information. I didn't have to put it inside an array. In an array, I could have put it into an object with appropriate keys for these two pieces of data. It doesn't really matter. I just stuck with the array as the return value. And so now, if I refactored my code, that means that my original book page is simply, invoking my custom hook in the usual way that you would expect it to, right? And again, my hook is being invoked at the top level within my component code, so I'm adhering to the rules of hooks. And it's a straightforward. This example was very straightforward. Sometimes they're not as straightforward, but it is in this case. So yeah, I'm just saying, in one sense, your custom hook is an ordinary function, but it can only be invoked, or should only be invoked, from a component code. It would only make sense if it's invoked from a component, clearly. And I've kind of already made the point about prefixing the function name. And I've already made the point that your custom hooks can return anything. Typically, though, if you look across a broad range of hooks that come with third-party libraries, they usually return a collection of things, whether it be a collection in the form of an array or a collection in the form of an object. In fact, the hooks that we will look at next week, which are part of some third-party libraries, they are returning objects, but you can return any type of information.